Okay, this is the P2 paper from June 2024. It's question number 3, and this is an exponentials and logarithms question. We're going to be looking at the laws of logarithms. We're going to look at solving equations using logarithms. Let's jump straight into part 1, and it says, use laws of logarithms to solve this equation here. So let's write it down. So we've got 2 log to the base 2 minus x is equal to 4 plus log 2 to the x plus 10. So the first thing I'm going to do is get both logs onto the same side. So 2 log 2 minus x minus log 2 x plus 10 equals 4. And then the first log rule I'm going to use is the fact that if we've got log a to the power of b, what we can do with that is take that power down. Alternatively, if we've got b log a, then that power can go up and become to the power of b. So those two are interchangeable. Here what we're going to do is we're going to take the power up there. So if we do that, we're going to get log to the base 2 of 2 minus x all squared minus log to the base 2 of x plus 10 equals 4. And now I can use another log rule, which is that log a minus log b is equal to log a over b. And we've got that scenario on the left hand side now. So log 2 minus x all squared minus log 2 x plus 10 can be written down as log 2, the first one, divided by the second one here. So we're going to get a combination of those two. Let's get rid of the log rule that I just used there. And then another thing that we can do with our logs is to have this idea. If I have log to the base a of b equals c, what I can do is I can change that log equation into a power equation, into a power statement here. So when we do that, we say the base of my power statement is going to be the same as the base of my logarithm. And you should all know that a logarithm is a power. So that must be the power part of it. So we can change that into log ab equals c can change into a to the power of c equals b. So if I do that over here on the left-hand side, the base stays the same. A logarithm is a power, so that must all be equal to 2 minus x all squared all over x plus 10. Again, let's just get rid of those log parts there. And now I've got a little bit of work to do, but this is just going to be a quadratic equation here. Let's just tidy it up. You might want to do this quicker than me. I'm going to do it relatively slowly. 16 is 2 minus x all squared over x plus 10, which gives me then 16x plus 10 is equal to 2 minus x all squared. Let's do both sides. So I'm going to get 16x plus 160 there. And 2 minus x all squared, you can take your time over it. I've already done it. It works out to be x squared minus 4x plus 4 when you multiply that all out. Make this look like our standard quadratic equation. X squared minus 20x minus 156 equals 0. Now they do this a lot. I don't know that necessarily everybody can factorize that. If you can't factorize it, put it into quadratic formula. Say, because I've done this already, I took a little bit of time to work out that the two numbers are multiplied together to make 156 are 6 and minus 26 there. But, you know, if it's the exam and you've not got a lot of time to do that, you could just as easily actually go through and use the quadratic formula to be able to work that out. Now, always when we're doing this, go back and just check, because sometimes some of these solutions don't work. Yeah, if I've got 26, then I'll get log of 2 minus 26 there, which will be a negative. I can't have that as being one of my solutions, so that is not a solution. My solution actually comes from x equals minus 6 in this stage, because if I get minus 6, I get 2 minus minus 6, that's log 8, and I get minus 6 plus 10, that's log 4. Both of those are okay to fit within a range of values that are acceptable. So yeah, be careful of that. That sometimes catches us out. Then the last part says, can we find the value of log square root or base square root a to the 6? Yeah, we can. Let's write it down and see what this is going to lead to. So part 2, it said log to the base square root of a to the 6. So all I'm going to do is I'm going to set that equal to x, and then I'm going to do what I did just a minute ago. I'll remind you again, if we have log ab equals c, I can make that a is my base, c is a power, so I can end up with that statement there. I'm going to do that with this one. So the base stays as the base, a logarithm is a power, so that means x will be the power there, is equal to what's left, the a to the 6. Right, what does a to, or root a x work out to be? Well, root a is a to the half to the power of x equals a to the 6. And then using our basic indices rules, I can say that's a to the half x equals a to the 6, which means half x equals 6, which means that x equals 12. There are quicker ways of doing it, but that's the simplest way to make sure it's like a foolproof method for being able to do that part of it. And then that's all of question 3 done. Hopefully that all makes sense to everybody.